Hello, hi everyone. Welcome to the Student the Brand. This is our Siva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. Okay, so let's start. Light reflection and refraction. So light is a form of energy. Light is a form of energy which gives the sensation of sight. We already know that. Okay, so light is a form of energy which gives the sensation of sight. Yes or no? So now purely we will discuss about light refraction. Light refraction. Okay, so let's start the topic with the intensive preparation. Okay, so light reflection and refraction. So already we discussed about light reflection. Light reflection. So now we have to discuss about light refraction. Light refraction. Light refraction. Light reflection and refraction, right? So light reflection already we discussed, and class 1, class 2 completed, so it will be there in the playlist. So this is class 3, that is light refraction. So class 1 about light reflection, class 2 about problems based on light reflection. Now this is a class 3 based on light refraction. Light refraction. Okay. Okay. All the best. All the best, ma. Keep it up. Keep doing. Keep rocking. Definitely you'll get. So light reflection. Light reflection and refraction. Light reflection and refraction. Refraction. Okay, light reflection and refraction. So in this topic, so completely we'll discuss about light refraction. First of all, what is a refraction? So refraction is nothing but when light ray is moving from one medium to another medium, that is nothing but rarer to denser. Rarer to denser, the path of the light changes. So at the interference of the two media. So where it changes? At the interference of the two media, the path of the light changes. The path of the light changes. That is called refraction. Okay. Bending of the light ray at the interference of the two media. Bending of the light ray at the interference of the two media. A path of the light changes at the interference of the two media is called refraction. Okay. So what is rarer medium and what is denser medium? Speed of light is more in the medium, that is rarer medium. Speed of light is less, or the particles present. Okay. So it will be occupied little space. So whereas denser medium, the particles are occupied more closer to each other. Okay. So here you can take. Hello sir. Hi, welcome to the class. So you are taking this rarer medium and denser medium. So those are watching the class, do like. Those are new to the channel, do like, share and subscribe. So click on bell icon. So whenever I'm taking live classes, you'll get notifications, because it is a right time to listen the classes. Okay, so very important. Already I'm creating the playlist. So important questions, important questions I'm creating into playlist, like a 3 marks question, so 2 marks question, where I am not able to cover in the class, so in the live class, those questions those questions I'll be converting in the form of shorts. So I'm posting in the playlist, so in the same playlist you can get it. So for this exam, so for upcoming exam, so I'm creating the playlist. In the playlist, so I'm adding all these classes. At the same time, I'm adding shorts also. So just check once, okay, check once. So those who have any doubts, you can so post in the comment section. I will try to respond. Okay, so I'll respond to post in the comment section. Okay, so now let's start. So I'm taking here this are rarer medium, denser medium. Light ray is passing from rarer to denser. So this is the normal line. The light ray is moving towards the normal line. So when light ray is moving from rarer to denser, it moves towards the normal line. Why? Speed is decreasing in the denser medium. Compared to rarer medium, speed is decreasing in the denser medium. Understood? So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. So the path of the light changes at the interference of the two media, or when light ray is moving from rarer to denser, so at the interference of the two media, it bends. Okay, so if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal. So when it is moving from rarer to denser, why it is bending? So speed is decreasing. At the same time, refractive index of the denser medium is more compared to the rarer medium. Understood? So because of these two factors, so light ray is bending towards the normal line. Light ray is bending towards the normal line. In the same case, if I assume, let's take, if the light ray is passing from denser to rarer, if the light ray is passing from denser to rarer, okay, so when it is entering denser to rarer, speed is increasing. At the same time, so refractive index of the rarer medium is less compared to the denser medium. Refractive index is more in the denser medium than in the rarer medium. So that is the reason. So by taking these two factors, the light ray is moving away from the normal line. Away from the normal line. I hope it is very clear, right? So now you can check once here. Check once. Okay. So check once here. So light ray is passing from rarer to denser. It bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. So which topic you want, ma? Which topic you want? Let me know. What is the topic name? At least if you let me know the topic name, then I can cover. So within the class, or I'll take 2 minutes or 3 minutes to explain your doubts. So let me know what is your exact doubt. Which topic? Topic name. If you tell, then I will try to answer to your question. Okay. So drop whatever you have doubts, just to drop in the comment section. So instead of waiting for your message, I can go with the concepts. So once you drop the question, now potential energy possessed by the body by virtue of its position or configuration is called potential energy. Potential energy. So P equal to mgh. P equal to mgh. That's enough. That is the potential energy, right? Energy possessed by the body. One question asks. So that is energy possessed by the body by virtue of its position or configuration is called potential energy. Potential energy formula is mgh. Okay. So P equal to mgh. That's enough. Understood? Centrifugal force. The force which is acting away from the center, the force which is acting towards center is called centripetal force. The force which is acting away from the center is called centrifugal force. Okay. So okay, come to the point. Next one. This is the rarer medium, denser medium, and denser medium, rarer medium. So if the light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, so the angle, this is the angle of incidence and angle of refraction. Angle of refraction. In the first case, if you observe, angle of incidence is greater than the angle of refraction. Point number 1. And here, angle of refraction is greater than the angle of incidence. Understood? So here in the first case, if you observe carefully, angle of incidence is greater than the angle of incidence. Angle of incidence is greater than the angle of refraction. Why, sir? Why you are saying like this? So because when light ray is moving from rarer to denser, bends towards the normal line because of speed is decreasing and refractive index of denser medium is more compared to the rarer medium. So that's why it is bending towards the normal line. So that angle is decreasing. So refracted angle is decreasing, right? This angle is decreasing compared to angle of incidence. So that's why. So angle of incidence is greater than the angle of refraction. And coming to here, angle of refraction is greater than the angle of incidence because when light ray is moving from denser to rarer, light ray is moving away from the normal line. Light ray is moving away from the normal line. So angle of refraction is greater than the angle of incidence. Understood? So this is about refraction. So three definitions we can say for a refraction. The bending of the light ray at the interference of the two media is called refraction, or path of the light changes at the interference of the two media is called refraction. So changing a light ray direction when it is passing from one medium to another medium at the interference of the two media. So at the interference of the two media, the light ray changes direction. Okay, so that is called refraction of light. Okay, so any definition you can take. So that is about refraction of light. So in the rarer medium, so when it is moving from rarer to denser, bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Yeah, definitely. So user ID Anjan. Yeah, definitely it forms complete image, but so intensity decreases. So compared to normal, so compared if you take a normal lens and send the light rays, the image will be forming. Compared to that image, when you cover half of the lens, so in this case, so complete image will form. Then intensity of the image will decreases. Okay, so we can say brightness or like that. So normally, minimum light rays are required to form the image of the object is 2. If 2 light rays are passing through the lens, that's enough. Image will form. If 2 light rays intersect after refraction, the image will form. That's enough. But half of the lens is covered, then automatically image will form. Okay. So I hope it is very clear doubt. If your doubt is clear, do like, share, and subscribe to Student the Brand and share to your friends. Okay. So come to the point. Next one. So next one is, so Snell's law will discuss. Snell's law. After that we'll go through the glass lab, everything. Glass lab. Point number 1. So if you have any doubts, you can do comment in the comment section. So after seeing question, so if it is relevant to the concept, definitely I will answer. Okay. Done. Come to the point now. So here you can see laws of refraction or Snell's law. Laws of refraction or Snell's law. So point number 1, incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. Okay. So incident ray, refracted ray, normal line lies on the same plane, and angle of incidence, sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incidence to sine of angle of refraction equal to constant. Very, very important. So laws of refraction. So in the laws of reflection, we'll get that one. So here the ratio sine of angle of incidence to sine of angle of refraction equal to constant. So constant is nothing but refractive index. Constant is nothing but okay. Thank you so much. Definitely. Okay. So now you can see laws of refraction. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. And coming to the point number 1, the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. Okay. So here there are two types are there. One is absolute refractive index, another one is relative refractive index. One is absolute refractive index, another one is relative refractive index. Coming to absolute refractive index, Absolute refractive index, that is n equal to c by v. N equal to c by v. So ratio of speed of light in vacuum by speed of light in medium. Ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Absolute refractive index. Understood? So here, so we'll discuss about absolute refractive index and relative refractive index. Absolute refractive index and relative refractive index. So n equal to c by v. N equal to c by v. This is absolute refractive index. Absolute refractive index. Absolute refractive index. Understood? So this absolute refractive index, that is nothing but ratio of speed of light in vacuum by speed of light in medium. Coming to relative refractive index. So when light ray is moving from one medium to another medium, when light ray is moving from one medium to another medium, so then we can say, so n12, if you are taking n1 by n2, that is equal to v2 by v1. v2 by v1. Once again observe here. So when light ray is passing from rarer to denser bends towards the normal line, this is the angle of incidence and angle of refraction. Angle of incidence and angle of refraction. Here you can observe absolute refractive index. What is absolute refractive index? So n equal to c by v. So ratio of speed of light in vacuum by speed of light in medium. And coming to n12 equal to n1 by n2 equal to v2 by v1. So that is also we can write n21 equal to n2 by n1, that is nothing but v1 by v2. v1 by v2. So we can take like this. Once observe. So whatever the medium comes first, that you have to write in the numerator. Next one you have to write in the denominator. Okay. So whatever the medium comes, that medium you have to write in the numerator. So remaining you have to write in the denominator. Okay. So check once here. So do like, share and subscribe. Click on bell icon. So you'll get live updates. Okay. So like you will get a live class updates. Okay. Whenever I am taking live class, you'll get notifications. So that's why click on the subscribe button. Click on bell icon. So you'll get live class updation. So this is the right time. This is a high moment. So you have to learn carefully. So that's why click on subscribe button, click on like button. So share to your friends, ask them to join to the class. Okay. So and I'm creating the playlist for CBSE grade 10. Okay. So exclusively for this exam, important questions, important shorts. Okay. So which I'm not able to cover in the class, those I'm creating like a shorts and uploading in the playlist. Just check once. And the live classes anyway it will be updated. So this is my third class, class 3 this is. So already I took 2 classes. So this is the class 3. Okay. So class 3. Next one check once. One check. So you'll get to know. Okay. Done. Come to the point. So absolute refractive index n equal to c by v. Relative refractive index n2 equal to n1 by n2, that is equal to v2 by v1. n21 equal to n2 by n1, that is equal to v1 by v2. v1 by v2. I hope it is very clear. So this is about absolute refractive index and relative refractive index. Relative refractive index. The next one we will discuss about one more. That is, so that question is, so we'll go to the critical angle and total internal reflection. Critical angle and total internal reflection. So just check once here. So here I am taking this. So this is the rarer medium and denser medium. So the condition is very important. So light rays should move from denser medium to rarer medium. Light rays should move from denser medium to rarer medium. So that is a condition. So here this is the source. So light ray is passing like this. So I am taking here. So I am considering this a normal line. Light ray is moving away from it. The angle between incident ray, this angle of incident, angle between reflected ray and normal line is called angle of refraction. Okay, so if the light ray is passing from denser to rarer, so like this, and this one is the normal line. So the angle at which, okay, certain angle. Normally I'm keep on sending the light ray. So here I'm keep on sending the light ray. It is moving like this, and again it is moving like this, and again it is moving like this, and again it is moving like this, and keep on I'm sending. So that light ray is moving right now. So denser to error. But at certain angle of incidence, the ray passes along the surface, gauges along the surface, or moves along the surface. Okay. So at certain angle of incidence, the refracted ray passes or gauges or moves along the surface at certain angle of incidence, or it makes 90 degrees with the normal line. That is nothing but critical angle. At certain angle of incidence. So the refracted ray makes 90 degrees with the normal line. That angle is called critical angle. Understood? So, okay, so I'm taking here. You can observe. So here I'm taking one more light ray. I'm taking like this. If it is passing like this, okay, so here you can observe. This is the normal line. This is a normal line at certain angle of incidence. So the refracted ray makes This is the refracted ray. So it makes more than 90 degrees. Here 90 or theta or more than critical angle. We can say more than critical angle. The refracted ray makes more than critical angle. Then that light ray reflect back into the same medium. So what is that medium? Same medium is denser medium only, right? Same medium. Okay, so here you can observe. So normally light ray is passing from denser to rarer, it moves away from the normal line. That is the refraction. So if it is moving from denser to rarer, and at certain angle of incidence, the refracted ray passes or gauges. Because of this angle only, that light ray, this refracted ray passes or moves or gauges along the surface. Understood? Or making 90 degrees with the normal line. That angle is called critical angle. This angle is called critical angle. Okay? This angle is called critical angle. Understood? And here once again you can observe here. If the light ray is passing from denser to rarer, so it makes more than 90 degrees, or more than critical angle. That is 90 plus theta. Then light ray reflect back into the same medium. Okay, this is called total internal reflection. I hope it is very clear. So next one. So we'll discuss about glass prism. So actually this question they given in the exam. So that is, draw the path of the light ray when it is passing through the transparent glass slab. Okay. So normally you can see this is the incident ray, and this one is the normal line. Incident ray and normal line. Okay, so I'm considering here. So this is the normal line. Okay, and here is the refracted ray, and this is a normal line, and this is the emergent ray. Understood? So light ray is passing from rarer to denser because the glass slab is a denser medium. So this is a air and air, this is a glass, denser medium. Okay, air and glass. This is the air and glass. Understood? So if the light ray is passing from air to glass, it bends towards the normal line. If the light ray is passing from air to glass, it bends towards the normal line. Air to glass, it bends towards the normal line. So because of refraction of light. So if you are extending this light ray, that is the initial direction of the incident ray, the distance between emergent ray. So angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. And the angle between emergent ray and initial direction of the incident ray is called lateral displacement. lateral displacement or lateral shift. Lateral displacement or lateral shift. Understood? I hope it is very clear. So next one you can see. So this is about lateral displacement or lateral shift. And one more thing you can see. So I'm taking the glass slab like this. This is a glass slab I'm taking here. So here is a person. The person can't able to see the coin placed at the bottom of the beaker. So you can't able to see the coin placed at the bottom of the beaker. So when we pour water, what happens? The coin position rises up. The coin position rises up. Okay. So the coin position appears here. So above the actual position, So that is the coin actual position, but it appears here. It appears here. This position, understood or not? So this thing, the distance between actual position to apparent position is called vertical shift. So this is the actual position of the coin. After pouring water, the position of the coin rises up. That time this person can able to see the coin position. Understood or not? This person can able to see the coin position. That is called vertical shift. Understood or not? So here you can observe. So incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. And one more thing. So the distance between emergent ray and initial direction of the incident ray. Emergent ray and initial direction of the incident ray is called lateral shift. Understood or not? Coming to vertical shift, the distance between actual position to apparent position. This is the actual position of the coin and this is apparent position of the coin. So the distance between actual position to apparent position of the coin is called vertical shift. And one more thing, if you place a pencil in the beaker, it appears to be bent. Okay. So water is filled here and you are placing the pencil. So this is the pencil position. Okay. So at the interference between water and air. So at this position, so the pencil position appears here like this, somewhat bent like this. But actually position is here like this only. Okay, so no changes in the pencil position, but due to refraction of light, the position of the pencil at the interference between air and water, at that position it appears to be bent. So this question, and one more thing is, if you place the lemon inside of the beaker, so I am taking this the beaker. So if you place the lemon inside, so water is filled inside of it. So water is there in the glass. Then if you place the lemon placed in the water appears bigger due to refraction of light. It appears bigger. Okay, so that's enough. So come to the point. Here you can observe incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Understood? And this is the initial direction of the incident ray. The distance between, so this is the distance between emergent ray and initial direction of the incident ray is called lateral displacement. And coming to the vertical displacement, so the distance between, vertical distance between actual position to apparent position of the coin. Is called vertical shift. Understood or not? And here you can see, if you take a pencil placed in the beaker, okay, at the interference between air and water, it appears to be bent. Actually, so pencil will be like that only. So it won't bend. But so due to refraction of light, it appears to be bent. Okay. So here at the interference between water and air. Understood? And coming to here, one more. So take a glass of water. And place lemon inside of it. So if you drop the lemon, if you place the lemon, okay, then it appears bigger. The lemon appears bigger in the water glass. Okay. So due to refraction of light. Due to refraction of light. I hope it is very clear. So these are the points related to refraction of light. So these are the points, very important, very important. Now we will go for a spherical lenses. Spherical lenses. Do like, share and subscribe to Student the Brand. Click on bell icon so you'll get notifications regarding the live classes. Stay updated to the channel. So once check the channel, you'll get to know. So complete discussion about the class. So this is the third class I'm taking. So already I took 2 classes. So it is there in the playlist. Class 1 is about reflection of light. Class 2 about problems related to reflection of light. Class 3 this one regarding the refraction. So based on this one problems also I'll do. So after that we'll go to the human and colorful world. Once check the videos. So I from long back onwards I'm keep on taking live classes. Once observe the videos, live classes. If you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand and share to your friends. So share to everyone, share as much as possible. So content is really good. So you can check the content. So definitely it will be worth it. At the same time you can able to prepare well. So once you see the live classes, once check the live classes, then you will get to know completely about content only. So regarding the physics only. So pure content related to physics. In-depth content I am giving. Related to CBSE physics. Okay. So just check once. Grade-10. Check once. Check the videos and understand the concept. Practice well. Do well in the exam. Okay. So now we'll discuss about lenses, spherical lenses. So I'm taking this a convex lens. This is a convex lens, and this also convex lens only. Okay, so this is the optic center, F1, 2F1, that is nothing but C1, F1, 2F1, and this side F2, 2F2, F2, 2F2. This is about a convex lens. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. So this is a concave lens. Okay, concave lens. This is a concave lens. Okay, so optic center F1, 2F1, F2, 2F2. So here I am taking this side and this side also I am considering. Okay, so this side also. So F1 to F1, F2 to F2. Convex lens and concave lens. This is convex lens. Convex lens is also known as converging lens, whereas convex lens is also known as concave lens. That is convex, this is concave. Concave lens. So convex lens is a converging lens. Whenever light falls on it, after refraction, the light rays will meet here. Okay, like this. And here you can see, whenever light rays are incidenting on it, after that, those light rays will diverge like this. Okay, if we are extending, those light rays will meet at focus, and here it is meeting at focus. Understood or not? I hope it is very clear. So convex lens is also known as converging lens. Concave lens is also known as diverging lens. So now we'll discuss about ray rules. Ray rules. This optic center F1 to F1, F2 to F2. Light ray is coming from infinity. After refraction, passes through focus. Light ray is coming from infinity. After refraction, passes through focus. 1, coming to 2. So, optic center F1 to F1, F2 to F2. So, light ray is passing through focus. Light ray is passing through focus after refraction. So, moves parallel to the principal axis. And coming to the third one. So, light ray is optic center F1 to F1, F2 to F2. So, light ray is passing through optic center. So, no deviation takes place. So, it goes straight like that. And coming to the concave lens. So, concave lens, only 3 cases are there. So, case number 1. So, here you can observe optic center F1 to F1, F2 to F2. So, light ray is passing like this. After refraction, it moves. This is a focus. That's the first one. Coming to the second one. Light ray is passing through focus. Optic center F1 to F1, F2 to F2. So, light ray is passing through focus. So, after refraction, it passes parallel to the principal axis. And coming to the next one, third one. So, this is the third one. You can observe optic center F1 to F1, F2 to F2. So, light ray is passing through optic center, no deviation takes place. So, these are the ray rules of convex lens and concave lens. These are the ray rules of convex lens and concave lens. So, do like, share and subscribe to Student the Brand. If you like the content, if you like the channel, so share to your friends, ask your friends to join to the class. So, ask them to join maximum number of students. So, inform to the near ones. So, that is a request from me to you all. Just inform to everyone regarding the channel, share to everyone. So, ask them to join, ask them to listen the class. Ask them to join to the class, ask them to listen to the class. If they like the content, if they like the channel, so if they like my explanation, so please do like, share and subscribe to Student the Brand and share to everyone. So share to everyone as much as possible because it's the right time. So you are helping your friends, you are helping your juniors. If you are junior, you are helping your senior. Okay, if you are senior, you are helping your junior. So, to whomever you are, to whomever this class is helpful, useful. Okay, so share to everyone. Share to everyone. So that is a request to you all. So thank you so much. And first of all, understand the class, listen the class, attend the class. So observe the class. If you like it, if you like the channel, if you like the content, if you like my explanation, so you can do share to all. Okay, so if parents are watching, so I'm requesting all the parents, please support. So please encourage the channel, please encourage me and give one chance. Okay, so share to everyone. So thank you so much for supporting. Those are really supporting me. Thank you so much. So no words to express. So thank you so much to you all. But those who are going to subscribe, those who are going to support, please observe the class, check the class. If you like the channel, if you like my explanation, if content is good, then please do like, share and subscribe and share to everyone, inform to everyone as much as possible, as soon as possible, because so even 1 minute also very important now, because now exam time. So share to everyone as much as possible, so make this concept to reach everyone, so make this class is useful to everyone, so then they will get to know, they will join to the class, they will attend, they will listen, they will understand, they will write exam with a great confidence. Okay, done. Come to the point. Next one. So convex lens, convex lens, convex lens. So convex lens. So optic center F1, 2F1, F2, 2F2. Object is at infinity. Object is at infinity. I am good. I am great. I am nice. Thank you so much for asking. Kaushik. Hi. So here you can see the light rays are coming from infinity. After refraction, those light rays are meeting at one point. Okay, object is at infinity, image is forming at f2. Nature of the image is real and inverted. Size of the image is highly diminished. So point number 1. Okay, so very very important. So just check once. So coming to the next one. So optic center F1, 2F1, F2, 2F2. So object is placed. So one light ray is passing through focus. Another light ray is passing through optic center. That light ray will meet between F2 and 2F2. F2 and 2F2. So to do work on my own, okay, so take lead role to my institution, that's why. That's the reason. So object is placed beyond 2F1. Beyond 2F1, image will form between F2 and 2F2. The nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. And coming to third one. Okay. So third one, object is placed optic center F1, 2F1, F2, 2F2. So object is placed at 2F1. So one light ray I am taking like this, it passes through focus. Another light ray passing through optic center. That light ray will meet here at 2F2. Okay. Object at 2F1. Image also will form at 2F2. So I am working in my student branch channel. So 2F2. Nature of the image is real and inverted. Size of the image is same size. Same size. Coming to the fourth one. Optic center F1, 2F1, F2, 2F2. Object is placed between 2F1 and F1. So image will form. So object is placed Between F1 to F1, one light ray I'm taking like this, it passes through. Another light ray is passing, and those light rays will meet beyond to F2. Okay, the image will form here. Okay, so here you can observe object is placed between 2F1 and F1. Image will form beyond to F2. Beyond to F2, nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. So right from starting of the channel, so I am like this only. So with a different attire, you can check. So here you can see optic center F1, 2F1, F2, 2F2. Object is placed at F. So one light ray I am taking like this, it passes through focus. Another light ray is passing through that one. So object is at F1, image will form at infinity. Nature of the image is so object is at F1, image is formed at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So coming to the last one. Last one is very, very important. So thank you so much. So with your blessings, definitely I will. So optic center F1, 2F1, F2, 2F2. Okay, object is placed between F1 and O. Object is placed between F1 and O. So one light I am taking like this. So inform to everyone, inform to your friends, ask your friends to join to the class. Okay, so then so here you can observe. So in this case, so object is placed between F1 and O. Image is forming same side of the object. Same side of the object. Nature of the image is virtual and erect. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. I hope it is very clear. So these are the points. If you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand. Inform to everyone. Ask your friends to join to the class. Okay, it is high time, right time to learn the concepts. Okay. Next one, concave lens. Only concave lenses 2 are there. Only concave lens. So image formations only 2 are there. We will discuss those. In concave lens, image formations. So concave lens only 2 image formations are there. So check once here. 2 image formation, those are So optic center F1, 2F1, F2, 2F2. So one light ray I am taking like this, it will diverge. Another light ray I am taking like this, so it diverges. So if you are extending this one, if your object is at infinity, image is forming at F1. Nature of the image is virtual erect. Virtual erect and nature of the image is virtual erect. Virtual erect and highly diminished because point size image is forming. So highly diminished and point size image is formed. So next one, two cases. So case 2, optic center F1, 2F1, F2, 2F2. So object is placed anywhere between optic center and O. One light ray I am taking, it passes through. So another light ray passing through optic center. The image will form here. So between F1 and O. So object is placed between optic center and infinity. Image will form between F1 and O. Nature of the image is virtual and erect. Size of the image is highly diminished. We can say diminished. Okay, diminished. Nature of the image is diminished. Object is placed between optic center and infinity. Image will form between F1 and O. Nature of the image is virtual, erect and diminished. So next one we will discuss about power of lens. The reciprocal of focal length is called power of lens, or simply we can say degree of converging or diverging. Degree of converging or diverging of lens achieved is known as power of lens, P equal to 1 by F. Okay. So SI unit of power of lens is depth. Power of lens is positive for convex lens. Power of lens is negative for concave lens. And lens formula 1 by F equal to 1 by V minus 1 by U. And magnification equal to height of the image by height of the object. That is V by U. So these are the points. So if you like the content, oh, thank you so much. So thank you. Okay, so do like, share and subscribe to Student the Brand. So thank you so much for joining and attending and listening my class. This is our Shiva sir from Student the Brand. So we'll see you in the next class. Signing off. Thank you. So right.